In our previous video, we talked about a bunch of systems of two by two, a bunch of two by two systems of linear equations that had um, one neat, nice solution. Okay, and we called those. We didn't mention this in the last video, but we typically call those consistent, independent systems of linear equations. Okay, and that means that there is one nice solution to our system of linear equations. Sometimes, though, we have a system that is called inconsistent, or a system that could be called consistent dependent. So if you have an inconsistent system of linear equations, that means there is no solution. So when you have a two by two system of linear equations, it'll look a little bit like this middle example here. You have two parallel lines. As both lines go off into positive and negative infinity, they are never going to cross each other. Therefore, we would say that is an inconsistent system of linear equations, and there is no solution. Another option here is that we have something called a consistent dependent system of linear equations. And that is where both lines in your system of linear equations, even though they might look a little bit different in how they're written, they actually take up the exact same line. Okay, you can't really see that here in how I've written this because it's kind of hard to do that. But in this situation, you're actually going to have an infinite number of solutions. So there'll be an infinite number of points of intersection between the two lines because they're effectively the same line. So let's look at a couple of examples and see if we can identify which type of solution we're going to have. So this first one, we have x plus 2y equals 6, and we have negative x minus 2y equals 6 as well. So this is like a really good candidate for just basic addition, because we have this x and the negative x. Okay, so let's go ahead and add them. So x plus negative x is 0. Then we have 2y plus negative 2y. That's also 0. And then we have 6 plus 6, which is 12. Okay? So we end up with 0 equals 12. And since that is nonsense, that's not true, we can now confidently say that this system of linear equations, in fact, has no solution. Okay? And because it has no solution, it is an inconsistent system of linear equations. And because this is a 2 by 2 system, that means we're actually looking at two parallel lines here. So there's no solution to this system of linear equations. You can go ahead and stop there. If you ever reduce everything down and get two constants equal to each other that are in fact not equal to each other, you can assume there is no solution and be done. Okay, so this is an inconsistent system of linear equations. Let's take a look at this one. Here we have x plus 4y equals 4, and then we have negative x minus 4y equals negative 4. Okay, again, this looks like a really good candidate for basic addition because we have this x and the negative x here. So x plus negative x is 0. 4y plus negative 4y, again, that's 0. But then we have 4 plus negative 4, which is, again, 0. So we're left with 0 equals 0, which that is true. So we'll check mark there. That's true. And therefore, we can say that this has an infinite number of solutions. Okay, there are an infinite number of values we can plug in for x and y, and this system of equations should work. Okay, and so that means we have a a consistent dependent system of linear equations here. All right, and given that, that means they represent the same line. So just for fun, let's go ahead and see if we can find. We can go ahead and find that line. Okay. So now, since they represent the same line, we can pick either of these and solve for y, and we should be able to find what the equation for the line is. So let's take this top example here, and we can go ahead and rewrite this as 4y is equal to negative x plus 4. Now we can divide both sides of the equation by 4. And we get y equals negative 1/4 x plus 1. And that is the equation that both of these lines are representing. And if you want to check the other one, we can go ahead and do that too. Let's see if we can solve the other one and get it into this equation as well. So we have negative x minus 4y equals negative 4. Let's add x to both sides, and we'll end up with negative 4y equals x minus 4. Dividing both sides by negative 4, we end up with y equals negative 1/4 x plus negative 4 over 4, which is just 1. So there we go. We get the exact same equation back. So we're actually looking at the same equation here, and therefore we have a consistent dependent system of linear equations.